I'm learning. Hi and welcome everyone. I can see people are joining in, dropping in one by one. I think people are tired in May. It's so much to do, right?
Yeah, we are tired here as well.
Yeah. But you are also super ready.
Yes,
I'm so excited, or we are super excited because this topic is, we're going to do some baking with innovation, not baking, bake innovations with data and AI. And it's in English. That's why I speak English today, guys. You cannot speak to me, participants, not by voice at least, but you can use the chat. And I would love if you could try it out right away. Just write something in the chat so I know you're there. Let's see. Hello, good morning. Oh, that's perfect. You're alive. Hi from Tibro. Nice. Warm welcome, guys. So nice to see you here. Up and awake. Cool. We use Zoom, and as I said, you cannot be seen or heard. So don't worry, just sit down and relax. But also, together with us today, together with Erika and Fredrik, we have Lynn. She is in the background, and she can answer questions in the Q&A function about a job at Smartr. And I think that you're also going to tell us more about Smartr, because we're so curious, of course. And I'm just going to hand over the mic to you guys. Fredrik and Erika, warm welcome here.
Thank you.
Thank you. So live broadcasting from our little kitchen at the office in Gothenburg.
Yeah.
Do we have anyone from Gothenburg in the chat? Maybe not. Maybe.
Oh, complete silence. No.
The silence.
All right. So yeah, do you see our screen?
It looks really good.
Okay, welcome. Today I'm gonna have this breakfast seminar. So we have from Smartr, and we're gonna introduce one of our data innovation frameworks that we use with a lot of customers, and we're gonna introduce you to it as well. So perhaps you can use in your upcoming journey, or when working with clients, or perhaps you're gonna get inspired and gonna develop something on your own. And usually when we start with this breakfast series or just with a data bakery, we really like starting with this quote. So the real magic of discovery lies not in seeking new landscapes, but in having new eyes. It's all about the changing the perspective. And that's what we're gonna talk today. How can you twist your mindset and change this perspective a little bit to look at the data like in a completely different way, that it becomes easy to talk, easy to approach, it's not intimidating at all, and it's something that you can relate to and something that you can make great concepts out of it. So today, very briefly, of course, we're going to talk about ourselves. We're going to talk like how the data is a gold mine for business, also how AI comes in the mix and how it makes the whole data and AI as a strategic enabler, also a little bit on data innovation and the data bakery. So who am I? So my name is Erika. I have extremely long last name. I come from Lithuania. And as Smartr, I work as a data visualization analyst, but I also work as a business developer as well. And with me is my colleague.
Fredrik Ring, much shorter last name to compensate, so it balances out, I think. I'm a machine learning engineer at Smartr, also a business developer. So I'm really engaged in both helping our clients understand what we can do with data and also building those solutions for them. And I think just like you said, the company that we come from is called Smartr. And we're a consulting company that very much lives and breathes data and AI. And we try to help our customers in this data journey that we're all sort of on now of embracing and using data to make value from it. And we do that from three different perspectives. The first one you should see in the top left here is the data-driven development and innovation. That's where we help our customers understand how we can approach data, how we can use data and apply it in our businesses to make use of it. So it's not just something that we add on top of our business, but something that can penetrate through the business and really propagate through all our areas in the business. And we also work with AI technology. So we build these solutions that can help you reach further from this data-driven concept ideation. And we also provide just regular analytics or advanced analytics to show business intelligence, to create good visualizations and help you understand what data is telling you. And you can see all our beautiful colleagues there at the top right as well.
And we participate in different areas where we extract this greater value from data. So we're very heavily involved in research and development projects that are part of EU or Vinnova funds. Also, we have our concepts, which is the data bakery, the data innovation framework. Also, we have academy. We teach data science for business controllers, and we are developing ourselves and others when it comes to data science and machine learning. Also, we are expert in a more technical as a more technical resource and also strategical partners for many other companies that need support when it comes to AI or technical development. And we're also involved in startups. So we recently were part of developing JobNet. It's a great platform for looking for a job. So we're actually having a launch party today in the evening.
Looking forward to that. And as you can see, we approach data from many different ways. And that is because data really is so important. And that is why we're here wanting to talk to you guys about data as well. Just like many other technical advancements that have been made throughout history, like the wheel or time or electricity or computers before that, they've all transformed the way that we live our lives and the way that we work on a daily basis. And data and data-driven algorithms are really what is transforming our current time right now. So we really think that data is a valuable resource, and we want to spread that idea. And of course, we already see this all around us with the biggest companies like Apple and Facebook or Meta and Google and these big guys. They're all using data as a core part of their business, and it's something spreading throughout all our society. And we want to make sure that idea propagates by speaking more about data. But when we talk about extracting value from data, we also want to point out that that's not just a simple process. It's not just gathering data and then you have this gold mine ready for you to just spend all that gold. You have to work to get the value from it as well. And that is, I think, something that this image shows quite well in the value chain of working with data. That first we have data, but we need to bring in context to understand what the information in that data is. And then the more we work with it, we improve until we have knowledge and insights and wisdom and eventually impact, where we're iteratively improving or transforming our businesses or society in general. And that's how we want to work. That's the direction we want to go in.
So when you actually use this data correctly and you end up with making the impact, it can really transform your business. So all these insights you extract from data can really change the way you produce your products or services. It can really help you to craft them and really help you to stay competitive in the market. Also, with the help of AI, you can extract and perhaps build very customized solutions to problems that before were perhaps not imaginable, or you couldn't solve it with a human eye. And also, like this data, it can really help you to transform business models as well and shift from product-based models to product as a service. So let's say if we would take a quick example, Netflix, before that it was just a DVD rental shop. And just because they started collecting a lot of data, analyzing what their customers want, they were able to actually shift to providing video as a service or video streaming services rather than just give rentals. And I also want to stay with the Netflix example and really show when Netflix really started leveraging this data. And it became crystal clear in 2013 when Netflix executives took like unusually aggressive decision to invest 100 millions into a TV show. And that was a little bit strange in 2013 because at that time Netflix didn't have like nothing originally made by Netflix. Everything was like taken from other news streams, other like movie partners, and they invested. And the reason why they were so confident in investing is because they analyzed the data of 30 million subscribers, and they that like all the audience, they particularly like David Fincher directed movies such as The Social Network. Then they really the other part of the audience really likes staring Kevin Spacey. And they also like realized that many people downloaded the British House of Cards. So they're like, what if we take all these insights we get from the data, we build American House of Cards. Kevin Spacey is still the staring character. And then David Fincher would direct the movie. And it was an absolute success. And that's how an example how Netflix utilizes data. So you can see that data is a strategic resource, and data is a key component and enabler in more or less every invention today. So with the help of data, we can either focus on increasing the revenues or minimizing the cost. And we do that by using this data to improve the business models or to really understand our and really customize our products or services. Also by focusing on internal processes, so on process optimization, also really identifying those pitfalls when it comes in the supply chains, really using this data drive our decision-making process and move from intuitive thinking to really rational thinking that is based with specific knowledge, and also really improve customer experience. So data is a gold mine for any organization today. And especially when you add AI and machine learning to that mix, you can create even more new opportunities. It becomes a strategic enabler, not just an enabler. So you don't need to understand AI perfectly in order to understand what are the possibilities. Fredrik in a second will explain AI a little bit more in depth. But what I like to say, sometimes you can think about like, let's say like these 4 keywords, which are just an examples. There are way more keywords you can describe AI. But let's say the first one is like you can predict the sales, you can predict how many people will come in the shop, you can forecast the weather, you can predict a lot of things depending on what you want to predict. You can recognize, so you can recognize an image from a set of images, an object from a set of objects, or like even when you take your phone and it recognizes your face and it unlocks. That's also the feature that AI that is used with the help of AI. And also you can personalize. You can use recommendation systems to personalize the content. That's what Netflix does. Also, that's what YouTube does, and a lot of many other companies. And also you can uncover structure. So this is interesting. So something that we cannot see with our regular eye. So you can identify fraudulent transactions in the bank data that is not really visible otherwise. So you can identify the spikes in energy use. So you can try like to identify what has happened, why we have those specific spikes. So with the help of AI, you can do a lot of great things.
And we'll just stay on this concept for just a little while longer. We know that you are connected to tech, so we want to give you a bit more value in just the knowledge of what are these algorithms, how do they work. So we won't go too deep into it, but just give you an overview of how it works so that you have that understanding and maybe can start even applying it if you're interested. But this is a great start, I think, to just look at how it has evolved over time. And as you can see from the timeline in the bottom, artificial intelligence really has been with us for quite some time now. This timeline is early in the 1950s already. And when we think about artificial intelligence, maybe it's hard to connect that back to the 50s, but really it's more than just these human robots that are trying to mimic being a human. It's more than that. It's trying to reach human intelligence in a way. And in the 1980s, we started talking about something called machine learning, which I'm sure you've all heard about. And what this is we're not just trying to achieve human intelligence, we're trying to achieve it by these algorithms learning how to get there themselves. That's why we call it machine learning. So these algorithms are teaching themselves how to complete a task or understand a problem. We're not providing the logic for them. And this has been around since the 80s, these ideas, but of course it didn't have the same impact then as now, just due to the fact that we have so much more digital data now and the computational power needed to train these models so that we can actually take advantage of what this technology actually can bring us. And this is something we've seen a lot in the last decade, where deep learning really has bloomed, which is more complex and advanced ways of working with machine learning, where you can have more complex problems to solve as well. And this really has set the stage for everything from autonomous vehicles to the digital assistants that we have in our phones now. But you might wonder how it works. So I think we should get a little bit into that. And the best way to describe it is through the analogy of the human brain, because that is really where these concepts come from. So our brains are comprised of many brain cells. Maybe you've seen them before, maybe not. They look something like this. This is the illustration. We have millions and millions of these brain cells called neurons in our brain that are constantly sending signals to each other and picking up on its neighbor signals and transforming that and sending some other signal on. And that is how we think, that is how we act, that is how I'm talking right now, just signals in the brain. And these neurons, the brain cells, are comprised of three main components. The first one being antennas that receive information from its neighboring cells. Then we have a processing unit that determines sort of what to do with all of these signals, all the information. And then we have a tail that sort of sends a response, a signal alarm. All right, so this is how it works in the big network of neurons that is our brain. And this is also how we build, with programming and math, the artificial neurons that drive this technology behind machine learning and deep learning. And as you can see, they sort of have the same structure. We have the antennas, which gathers information from neighbors. We have a processing unit and we have a tail. So this is something that we just program and build with math, but it's the same structure. And just like our brain is built up of a huge network of many of these cells, we build up an artificial neural network from many of these artificial digital neurons, as you can see in the right image. And this is how we construct a big network that is able to learn how to handle a task on its own. It can learn how to produce an output, how to complete the task without us telling it how it should do it. And as you can see, it's structured in layers here. And the more of these layers you have, the deeper the network is said to be. And that's where the term deep knowledge comes from. It's just many, many layers of these neurons that try to mimic what the neurons in our brain is doing. But you might ask, how does it learn on its own then? We just seen the structure, but how does it actually work? And I think a good way to understand that is by comparing it to traditional software. So as you know, this is somewhat of a representation of how traditional software works. Put to a computer. So we provide logic to a computer that also gets an input, and the computer just follows that recipe and provides an output. Provide the logic, meaning that the computer just had to go step by step what we wrote in code and execute that. And when it does that, it will be able to solve the task at hand. But this also means that all the problems that we can come up with a solution for, that we can program, those are the tasks that we can solve. If we can't find a solution, then we can't really code that solution in either. So these algorithms are bound or constrained by our intelligence. When we work with self-learning AI, on the other hand, you can see that there's sort of a shift here, that something is different. We no longer provide the logic here, but instead we provide inputs and the correct output, the expected output, what we want these algorithms to produce. And from that, the algorithms will learn the underlying structures and the patterns that connect the input and the output, and create its own logic for how they belong together. So how do we get from point A, the input, to point B, the output? The algorithms learn themselves that path, the logic behind that. And this logic is then used just as we use logic in regular traditional software. We can use logic as a recipe and provide new input, and then we'll get an output. So these parts are completely identical. It's logic, it's output, it's input, and that creates an output. The thing that's different is that we have a prerequisite step with self-learning AI. We need the algorithm to then first learn the logic. And this means that since it's learning the logic on its own, it can reach further and more complex solutions to problems that we might not be able to understand at all. And that is what makes these algorithms so powerful. Yes. And that learning process is very much like how we learn when we're combating a new task. They learn by training and training more and more on that task over and over again. And more specifically, this is done in 4 steps. So first, the algorithm will try to guess output from an input. It doesn't know anything yet, so of course it will do wrong. So how wrong the algorithm is, how wrong is this answer? And then we update internal parameters to make that error smaller so that it's less wrong. And then we start over again from the first step with a new input. And we do this over and over again until the algorithm sort of has tuned itself to understand the patterns, the underlying logic within the problem. And the way that we update these parameters to reduce the error, that might sound like magic, but it's very much like when you use an old-timey radio where you have to tune it to the correct frequency. If it sounds noisy when you're listening to the radio, you tune it a bit to make it less noisy. That is exactly the same thing we do with these algorithms. If they are wrong, we tune it a bit so it's less wrong, it's less noisy. With the difference being that a radio has one knob to tune, and these algorithms can have many millions of knobs to tune at the same time. But otherwise, it's analogous. And this is one way to make sure that we create good value from data. And this is really something that we want to do. We want to extract the value in data and take advantage of it.
So why do we do this? Because data-driven organizations are way more successful. And in McKinsey research, it was said that 23 times more likely to acquire customers. It means getting more revenues, making more profits, and staying relevant. And that's what is important in nowadays society. If you are a business, you want to stay relevant, you want to acquire those customers, and you want to make sales out of it. So how do you start? We have mentioned so many things, but how do you start? So we as a consultants, we have discovered three barriers in organizations that really were like a huge obstacles of working and achieving those things that we are talking about. So the first one was like the big barriers, hard to talk about data. So in organizations, we usually have different areas. So we have the tech teams, the tech departments, then we have the business departments, and then we have the customer focused departments. So usually when we look at the business department and when we ask them like, what is data for you? They very much like sales, can be sell a product, can be sell a product, can be make revenue from a product. They're very much like into marketing, business, and really generating the value. And then when we talk with the customer focused department, like what is data for you? They're very much like what is needed in order to develop this product or service. What do our customers want? And what is like has to be like so unique and specific about that specific product or service. And then when we talk with tech teams, they're very much about the scalability, reliability, the quality of data, the actual feasibility. So when you put all these 3 different departments in one room and you say like, right now you have to build a product, they very much get like misaligned because it's very hard to connect when we speak those different languages. So to a large extent, we still work in silos. So every team starts working on their own idea and they start investing time. And that leads that it's very hard to test hypothesis, and validation comes often very late in the process. And validation should come very early in the process. That's extremely important because every time before we build a concept, we want to validate it very quickly and make sure we're not investing time and resources in something that we don't need. And that happens many times, like organizations start building product. The customer team is like, but the customers don't really need this, or the tech team, we cannot really build it further. We don't have the data we need. So we wanted to create something that really helps like to create this joint view between those departments, puts like a clear vision and holistic approach, makes and really has like this, that all these departments, once they come in one room, has the same language, and we can really like lower the threshold when we talk about the data. We can really democratize the data language, and we always put those three perspectives, because this is crucial. Desirability, the human, that's something that we build is wanted. The viability, that's something that we can sell, and also feasibility, that we actually have the technical resources in the organization to build it.
And we also wanted to make sure that it was fun to work with, that it isn't a high threshold to get started of working with this data innovation. And that's where the data bakery metaphor comes in, which is just like data on its own really isn't valuable enough right there. We have to work it. We have to bake something from it. And it's the actual end result, the pastries that really drive the value that we can create from it. And that's just the baking analogy. We have to find our ingredients. What is the data that we should use? Where is that stored? Is it in the fridge? Is it in the cabin? Where is it? And then how do we mix and blend it? You know, combining just flour and egg and milk in different ratios will create extremely different types of pastries or baking things. But we need to understand how to bake it. What are the ratios that we should use? How should we bake and plate this so that it actually becomes a concept that is worthwhile? And then how should we distribute it? How should others get to taste our beautiful and tasty pastry that we have made, to make sure that the value that is generated actually reaches the customer?
And this is extremely crucial. We always have to make sure we distribute it. You're not going to make waffles, place it at home, and then just go to work and just hope that someone is going to benefit. This is going to be useless. And that's exactly when we develop those data-driven concepts. We want to use it in a way that improves someone's decision-making process and drives that impact, makes that impact. So again, on a very high level, we think about the data as ingredients. You check the quality of ingredients, you identify whether you have them in your own kitchen, whether you need to get like some from the grocery store, from the third external sources. You also blend using knowledge, and also very much like at the very end point, distribute it. You make sure that someone is actually using it and it's actually creating a greater value. So when we have this data baking analogy, like all these our bakers and all these little humans that we work with, they live somewhere in our baking house. So this is our workshop canvas that we usually use for workshops, with a lot of sticky notes all over the place. And like this baking analogy really helps to break down the complexity of working with data, because this little switch can really help people to relate how they act in the kitchen, and they can really help them to understand the data and really feel at ease when they talk about it. And the storytelling aspect that we in the house and the baking analogy, and we need to find the customers, distribute, really helps to remember and understand the methods and the concepts we talk about. And the service design principles always place the customer at the core, making sure we're always solving the right problem and we validating it quickly.
Yeah, and working with it in this way also ensures that we're lowering that threshold of creating these workshops. And that is do these data bakery workshops. Exactly.
Yeah. So we are a little bit rushing because we don't have like that much time. Usually after playing this data bakery, we start developing the recipe cards, because how is the bakery without recipe cards? And in the recipe cards, we very much like everything is defined what you need for a product, or more or less like it's a summary of the baking house. And after we develop those recipe cards, then we do prioritization. What kind of cakes do we like to bake?
Those that are delicious, but also simple to make. So we make sure that on this axis scale that you can see of trouble and value, we want to make sure that it's as low value of value as possible, so that we're taking those low-hanging fruits, those delicious, simple cakes.
Exactly, low complexity and a high added value. So this data bakery, I really hope like one day we're gonna have an opportunity to play this workshop with you. It's very much like human-centered, and it's very co-creative, really encourages collaboration. And remember, collaboration is the key when it comes to the innovation, and especially to data innovation processes. Also, it helps us to produce something very tangible while we can not invest that much time, but really quickly produce and prioritize, and really has like this holistic approach and a holistic view when it comes to it. And what we try to achieve at the Data Bakery, we try like to create like this an inclusive environment for different people with different backgrounds, competences, and perspectives to work productively and meaningfully.
And with that, we're coming to an end. So let's just quickly sum up this in three main takeaways that we want you to leave this session with. And the first one is just the potential of data, that it really is a gold mine for businesses. And we really see it as the enabler, the advantage that can help you reach further and be more competitive in your business by using that data, that knowledge that comes from it. But it is hard. There are obstacles. And usually they are more about the culture than the technical feasibility, because the data is usually available. They are there in our systems, but it's how we use it. How can we make value from it? That is the hard part. And that is what we're trying to solve with the Data Bakery. We're trying to help our clients and those we do this workshop for to kickstart the data-driven journey and make it easy and fun to start talking about data. And I hope you understand that from what we've said today.
And if you want to contact us, we left our email addresses there. You can also connect us on LinkedIn. And yeah, that's it for today.
That's it. Yes. Thank you.
Silent clap. I think people are clapping at home too. So nice. They're writing thank you in the chat. Thank you. Thank you. This is so interesting. And also, I feel like people want to know more about your backgrounds. Like, how did you end up here? Like,
yeah, how did you end up here?
So my background. So for my bachelor's, I studied economics, and for my master's, I studied data science. I studied in the Netherlands, and I ended up in Sweden very randomly, followed by love. So I got brought here like by my partner, and right now I live here, and I am very happy. And yeah, and how I ended up at Smartr, also very randomly, just mutual interests in data science.
Yeah, I think the interest for data is really, and for sustainability, is really what brings us all together. My background was in engineering physics at Chalmers but I more and more started to niche myself towards data and AI when I saw the potential and how much fun it was to work with, honestly. And I really feel like we can make an impact now. The time is sort of right for this area right now.
That's so cool. Because someone asked, we have a lot of questions. I know that Lynn, you have also answered them. I'm gonna take some of them anyway, so we can highlight them. And let's see, what backgrounds, and they also like, what kind of courses or programs do you recommend someone who is not in this field yet? I'm a total beginner. That's a tricky one.
Yeah, really good free online sources to get going, because the threshold really isn't that large to start. And I think one course that I would recommend is there's a course called Data Science Specialization that is provided from I think it's called deeplearning.io. It's by this guru called Andrew, who is really a godfather of this field, that is focused on data science. And there's another course focused on machine learning that is just called Machine Learning that you can find on Coursera. And it's an online course over a bunch of weeks with just a few hours every week that you can work with to really start working practically with machine learning, understanding how to apply it, which I'm sure you can bring onto your personal life or even your companies that you work with if you're already working straight away, because it's that graspable. I would really recommend those two courses.
Yeah, and also just like checking keywords as a design thinking in AI, that also helps like to put like a little bit different perspective on data science as well. And just like reading on data innovation, because everything is very much like interconnected. Yeah. So you very much like, it's always good to read up on a little bit different topics to get like this better understanding of the data science. It's a very like, it's a big umbrella of like a lot of like different things.
Yeah, Really, but I think that was really good tips, and I think we can add it to the email afterwards that we send along with the recording. If you didn't get it now, I'm also going to do it. All right, let's see if we have any more questions. You can still ask questions. We have 5 minutes left. Someone asked about Smartr. Do you live, because you live in Gothenburg, but do you also work remotely sometimes, or how do you work together basically?
I think there's a lot of freedom, and with that comes a lot of responsibility as well. But there's no set ways of having to be at the office all days of the week. We try to make sure that how we work is suitable to who we are as people. We're that few that we can actually be that flexible now. We try to be here at the office, different for different people, of course, and try to accommodate everyone's personal needs in that way.
Yeah.
But you work with, like, project-wise, you work with different customers, or how does it look like?
It's a mix. We do have consulting assignments where, let's say, we work like individually, like as a resource, but we also work as an agency. So we get the projects, and especially like Fredrik, you in tech team, so you like try to get on the projects as a team. So rather like individual person, like you try collaborate, break it down, and really like take like little particles of the project and solve it together. That's what we do as well. It really depends. We do different projects. We have internal projects. We have come to the agency, and then we have those consulting assignments. So it's a mix, and that's, I feel like, what it makes like very fun. I don't know like how my day is going to be tomorrow. It's like a lot of meetings, this and that, a little bit of brainstorming. It's very fun.
Yeah, there's really a bunch of different opportunities depending on what you like and how you like to work. So just like you said, we do both resource assignments where we go to the customer and make sure that we're doing work for them on a percentage basis of the week, so that we're there a certain amount of time, but also projects like that, which I think is really fun way of working. Just then you're working with your colleagues at the company, even though you're still a consultant, but we're doing the projects for them.
Oh, that sounds a lot of fun. Okay, so someone's asking, which programming language is the most usable to learn for this, and why? Do you know?
I would say hands down it's Python. Python is sort of the community embraced language for working with data science. There's a lot of libraries that make it easy to work and easy to use these different technologies and concepts that others have built. So you can just, what is it that people usually say, stand on top of the shoulders of giants. You don't have to build everything from scratch. There is a lot available that makes your daily life easier if you're working in Python. But I think there's a bunch of different programming languages that you can, so that's the one I would recommend.
Yeah, I'm not that much into programming at the moment, but I know that some of our colleagues using R as well. And they're very much into that. But I guess it depends, like, experimentation is the key. So check out which programming language is like the most familiar to you.
That's a great answer. Thank you. Oh, someone's writing, thank you. Interesting topic. It is indeed. And you who've been watching today, you can reach out to Fredrik and Erika, just as I said before. You can see the emails here, and we will also add the LinkedIn profiles to you guys, so you can connect afterwards and ask more questions, because now we have to end this. It's so sad, but I just want to thank you all for being here, and thank you, Fredrik and Erika, for this amazing topic. It's so interesting. And it's like a deep hole. You could continue forever, no?
Yeah, definitely. Yeah. Thank you, guys.
Yeah, thank you for hosting this. That was a very nice experience. Early morning.
Early morning, the best start of the morning. Thank you so much, guys.
It's a good start of the day.
It is. It's the best. Have a great Tuesday now.
You too.
You too. Bye.
Bye, everyone.